The objective of this lesson is to understand logarithms and be able to convert between logarithms and exponentials and back. Now, logarithms will be a new function. The basic idea and the big idea here is that logarithms are the inverse of an exponential. Let's start off by taking a look at our exponential function. Our exponential function that we've worked with is y equals b to the x. We're going to start off with an initial number of 1, so we're not going to have an a in front, in order to speed up the process of working with the inverse. Now, if you recall, to find the inverse of something, you swap the x and the y. So when we do that, the x and the y, when we swap them, we're going to get x equal to b to the y power. So for the inverse, when we want to try to get y by itself, to solve for y, we don't have a way of doing that. We don't want to take the y root of something to get rid of it out of that, because we then couldn't get y by itself. It'd still be the index of a problem. So what we have now is we create a function that will be the inverse, that we can write the notation using this, and that function is a logarithm. So the logarithm, the form that we use, is that we'll have y by itself equal to log base b. Now this little b here is a subscript. That means it's below the line. You've got to lower it. Just like you superscript with an exponent, you put it up higher. This subscript you got to put lower. It's similar to back in algebra when you did slope. You might have talked about x sub 1 and y sub 1. Those were subscripts. Well, to properly do this, you need this base to be lower than the line. And then we put the x in here. So log base b of x. So the way that this is read is y equals log base b of x. That is the notation we use, and that's how you read the notation with it. Now, when you look at this, notice that from this form, the answer to that log problem is the exponent on it. So what you want to recognize as a big idea for a logarithm is the answer to a log problem is the exponent. So whenever we do these problems, when you get on the other side of the equals from the log, you'll get the exponent as the answer to it. All right. Now let's go ahead and do our conversion. This is going to be our big idea for working with this, our objective actually, where we want to convert between exponentials and logs. If you have b to the y equals x, to convert that back and forth, you want to have y equals this formula, log base b of x. So this is the conversion we're going to use. The idea that I want to point out when using this is you want to recognize that this y is the exponent here, and the base b is what goes down below there. All right, so when converting, I'm going to use a little technique that I'm going to give credit to a colleague of mine, Jim Snowink. This is something that I learned from him to use this wording. He calls it circle tour, and what it does is it allows us to find the logarithmic form from the exponential by saying we're going to fill in some blanks here. We're going to have log base something of another number is equal to a number over here. We need to fill in all those boxes, and the way you do it is you start over here, and the first box is the first number here, so it's going to be the 4 is what we start with, log base 4, and then we circle over to the 64, that goes in the next box, log base 4 of 64 equals the 3, the exponent. Notice the exponent is the answer to the log. So the circle tour tells you the order that they go in. The log base 4 of 64 equals 3. So when we do the next one, we want to set up a log here. we start our circle tour, log base 7 of 1 over 49, so put a subscript here for the 7 down a little bit below the line, and then 1 over 49 is our inside of the log, equals the exponent, which is a -2. Let's try the next one. Notice that we have the same setup here. We're going to put log, and then the first number that we put here is the base, so log base 10. And then the next one we circle over here and put the 100 million. Equals the exponent. We come back to the other side, circle back, and get the 8 to get our answer to the log as the exponent. So log base 10 of 100 million is equal to 8. Now, what happens if we start in log form and we want to convert back to exponential? One critical thing, if you want to use, you can use circle tour still, but you have to start with the log on the left side. If the log's on the right, just move it over to the left and swap places, and then you can do the same thing. Notice we can do, for this one, we can do 3 to the 4th power is equal to 81. We're trying to fill that one out. 3 to the 4th is equal to 81. Now, notice you might be able to do this as well with just knowing that this is the base, the answer is the exponent, and the inside is what goes on the other side. So you can do it that way. If I want to do it that way, I go, the base is 5, the exponent is the answer to the log, so 5 to the -3rd equals the inside, 1 over 125. And notice that's the same if I did it with circle tour. 5 to the -3rd equals 1 over 125 for my answer. So this is the big idea of converting back and forth between exponential form. If you have the exponential, if you have the exponent on the left side, you can use circle tour. If you have the log on the left side, you can use circle tour. Both ways will help you as a tool to help you get the other form. Now what happens if you don't know the answer to these? For instance, if it says, let's evaluate log base 5 of 625. Now you can just think this through. This is the base. The answer is going to be the exponent. You could say 5 to what power equals 625, and you might know that that's equal to 4. If not, we can turn it into an exponential and solve the exponential by first setting it equal to x. This is just a technique. Set it equal to x. Now we're going to use the circle tour to do 5 to the x equals 625. Now I'm going to get the same base on both sides. Remember, that's what we do in order to solve. If you can get the same base, so you do 625 is 5 to the 4th. And then once you get the exponential with the same base on both sides, you can set the exponents equal, so the answer is 4. 5 to the 4th equals 625. Similarly for this one, we set it equal to x. We set it up with our circle tour. 3 to the x equals 1/9. And then we set up the other side by saying this is going to be 3 to the -2 power. 9 is equal to 3 squared. If I bring it up to the top of the problem, it becomes -2. So x equals -2 is my answer for that, and I get -2 for the solution. Now, so the idea here to introduce logarithms is to recognize the big ideas. Logarithms are the inverse of exponentials, and when we want to convert between the two of them, we use this guide that when you have it in this form, it becomes this form in the log and vice versa. But this technique of using the circle tour allows you to go from one to the other by saying log base 4 of 64 equals 3, remembering that the answer to a log is the exponent of the problem.